All right, hello. So today we will discuss about Inorder Traversal. So before attempting the question, we will understand what is Inorder. Let's see. All right. Okay, so we talked that what is Inorder Traversal. Inorder Traversal mean that when we are talking about some node, let's suppose tree. So it will say that I should be in between of my left subtree and my right subtree. So this is like Inorder Traversal. So we say that this should be my left, whatever, all the path, whatever on my left subtree, find it, then my value, then come to me, then go to the right. So let's go, we traverse like this. So we say go to the left, we ask the same question. What is on your left? What is your value? And what is on your right? Okay, left is not yet been calculated. Go to left. And then L, V, and R. So it will say go again, L, V, and R. So on its left, there is nothing. It will get back to that, okay, I have nothing. Left is done. What is my value? My value is 2. So it will say, okay, and then what about my right? On right, there is nothing also. We will get back, and we only get the value 2 here. So this is for Inorder Traversal 2, he get the value 2 only. So just for the sake of complete flow and how it should work, I would say be here. All right. Okay. So this node, when it will say what is on my left, he find nothing, and then he will say this is my value. Then go to the right, and he find nothing, so that will be his value. So I would say that this is what he will find. And then he will send this to its parent node for that, okay, this is my value. So he will send back there to its parent node, and then this parent node say, okay, this is my value 4, and then it will say what is on my right. He will send this control to the right, and the same flow happen for the right too. So it will say find nothing, and he will get the value 1. It will send the control back. So this is for the whole path. For this node, we will get this result when we go with Inorder Traversal. In Inorder Traversal, you can see this node, we ask this question, what is on your left, what is your value, and what is on your right? So we come across the solution that 2, 4, and 1. And then this value, this whole flow is being sent back to the parent of 5. And we get this 2, 4, 1 to the left of this parent 5. And then we get the value 7 from the right. The same flow goes up. So you can see this is from the left what we get. This is its value, and this is on its right. So then the whole path, the whole this path goes up. So we get that this is all together. This is left, this is my value, and this is on my right. And this is how the Inorder Traversal works. For the same flow, once again, so we'll say we come to the node, this node says go for my left, then my value, then right. So we have to just understand with this word Inorder Traversal. So we are saying that when the particle node will say that I should be in between of my left subtree and my right subtree. So this is Inorder Traversal. All right, so now we can start coding. So for the tree, we will say that we have a node, tree node with value int, left will be also a tree node, right would be also a tree node. And then we start writing, this is def in order with, we will pass him some root node against which we have to see Inorder Traversal. So this is tree node, and we are expecting that it will return the list of values of the tree. what it will be its implementation. So first I will ask about the question. Let's suppose we have a tree like this. This is the root node, and this is on its left 2, and then on its left nothing, on its right 5, and on the right of this tree there is 4. So if we will go with Inorder Traversal, what we are expecting, the expected output should be from this value. We are going left, we are, so it will go left, then nothing, we will get the value 2. Then from its right we will get the value 5, then is this 2 and 5 will go up to the parent and we will get the value 3, and then we will get the value 4 from its right. Now how we will implement that? The first thing that we start looking that this is a tree structure, and the same thing, there are two things are happening. The first that when we find nothing, we return nothing. The second, we find some node and we ask the same question, left, then my value, then the right, and append. So we are appending. So you can see for this node 2, we are appending whatever on this left and on this right. So this is the answer for Inorder Traversal for this. So we start using this using the pattern matching. We can say that for this root match, and we say like for the first case when we find nothing, we are going to return nil. We are not going to add anything in our answer. Case if we find some node, we will say as per our understanding what is Inorder Traversal, the left. So we say, oh, keep on doing in-ordering with the node left, and then whatever you will get from there, append it with node dot value. So we can't make node dot value because this triple colon function is actually looking for is a right associative and expecting some list on its right. So we say there is a list that has a value of current node value, and then we are going to prepend this with Inorder Traversal for node dot right. And as per our logic, that should be the output from this implementation. Let's implement that. So we said there is a val and root. We say tree node, and the value of the root is 3, and the left node will be tree node again, which is the value 2, and on the left is nothing. So we, let's suppose, make a simple implementation. We say that if you're not providing anything, make it right, and if you provide nothing, just make it right. So we provide the default value for them, and we say right. So we named the parameter with the tree node. The value should be 5 and nothing there. And for this for the right of this, we were saying there should be a tree node with value 4 and nothing there. So we say, okay, let's go and print ln Inorder Traversal for this node root. So from there, let's see what it prints for this. And let's say that the order should be like that. So here we go, 2, 5, 3, 4. So it is going with the exact 2, 5, 3, 4. All right, really thanks.